But otherwise, you have 3 more minutes. You are going to list some solutions to the inequality y less than or equal to 9.2, and then some solutions to the inequality 7 times the difference of 3 and x greater than 14. I do think you're capable of both. So in about 3 minutes, we'll call on you for some answers. We're going to go through all the tables for this first part of the answer. So, table 2, you'll start us off. What is a solution to the inequality y less than or equal to 9.2? So then the rest of you should not be table 2 as the floor. What are some solutions to the inequality y less than or equal to 9.2? 8. Right? Solutions to inequalities are values for the variable that make it true. Is 8 less than or equal to 9.2? Yeah, so that's true. Solution. Table 3, give me another. Table 4, another. Table 5, another. Table 6. Table 7. Sorry, buddy. Table 8. Table 9. And table 1. One that we haven't said yet. Okay. So I see some of us follow a certain pattern. Hopefully you know why these are all considered solutions, but those are all correct, right? Those are all smaller or less than 9.2, aren't they? Now, is 9.2 a solution?
Yeah.
Yes, because when plugged in, is it less than or equal to 9.2? So then yes. All of these are good examples, and if I were to plot it on a number line, so whoever spoke for your group in this little round, the reporter will now be whoever's to the left of that person, okay? If they're testing, obviously if they're testing, they don't count, okay? But here's my next question. Table 2, when I'm plotting this on the number line, where does my circle need to go? Close to the 9 on this side. So not on the 9 because it's not 9 exactly, but close to the 9 on this side is where it needs to be. In table 3, would it be open or closed? Closed. What part of the inequality tells you that, class? The little line underneath, if it's there, then it's a closed circle. If it's not there, then it's an open circle. Okay, so there's that. And unless it's an equation, then you should have an arrow pointing to where all your solutions are. So table 4, does my arrow need to point to the left or to the right? In what direction would be all the values less than or equal to 9.2? To the left. All right. So that covers the first question, a bit of review of what we learned on Monday. So hopefully that was easy. If not, you need to know that inequalities have a range of solutions. So like my solutions are all the numbers you said, all the decimals in between, and all the negatives up to like negative infinity. There's an infinite amount of solutions usually for inequalities. If there's a real world part to it, then maybe not all the negatives, but reasonably there's a range of answers versus an equation where there's just one. So that's like the new part of this unit that we are looking Then you had this, where you're actually having to do the isolating. Let me just rewrite it so that the 14 is not down here. But in this one, you did have to solve it. We learned how to solve on Monday. Granted, on Monday, it was just 2-step inequalities. Still though, when there's more than 2 steps, it's the same steps as equations, except for what? What's the only thing you need to worry about when you're solving inequalities? Sorry, one more time, please. Flipping the sign when what happened? Kristen?
You multiply or divide by a negative.
When you multiply or divide a negative on both sides of your symbol, then that's the only time it's ever different from equation. Just flip it if that happens. Otherwise, it's all the same steps. So that's why students tend to do better on this unit than like the one we just took a test on, because it's really repetitive with just a few minor differences. So let's see. Table 5, there are 2 good first steps you could have done to solve this, but what was your first step? Okay, I agree. I think distributing matches our traditional steps that I've taught you. But you'll also see another way on your test, so we are going to do both ways. So make sure you leave room to work it out twice. Yes. But first, I do agree that distributing is a good first step. If you see it can be done, usually you do that first. Table 6, can you tell me what you get from distributing?
So the first one.
Anything I'm missing? Okay, great. So whatever signs are on each number, like you keep the sign that's in front of it and follow your integer rules. So like a positive times a positive is a positive. Positive times a negative is a negative. Okay. But good, we distributed. Copying this over, you never flip the sign when you're just distributing, so just leave it how it is. And now table 7, can you tell me the next step?
The x side.
And I have 2 things I need to get rid of. What would I need to get rid of first? And class, how would I cancel the 21? Good. And whatever you do on one side of the symbol,
Leave it.
great. So then I get the negative 7x alone. Do I need to flip the sign when I subtract? Never when you subtract. So you just copy it, how it looks. 14 minus 21 is negative 7. All right. Table 8. What do I need to do now to isolate? Yeah.
Divide it by negative 7.
And class, whatever you do on one side. Do I need to flip the signs for that? Yes. Because we divided a negative on both sides, star highlighted, it can swing too. But that's when the sign flips. That's what you have to look out for. And then class, when I have the same thing on top and bottom of a fraction, what does it cancel out to? A 1. Positive 1. Negative divided by negative. So this, if you got this on your own, great. If not, well, we just did it, so hopefully you can continue doing it anytime you see it. Yes? When you multiply or divide a negative on both sides. That's when. Okay, so anytime you're doing something on both sides, just check. Is it one of those 2 things we talked about? But also on your test, you need to know this. There's another acceptable first step you could have done. Did anyone do something different that they'd like to share? Now, I still encourage you, distribute first if necessary. I feel like you'll get the right answer more of the time, but you will have questions on your test that have you finding an error or seeing if something's acceptable or not. you might see someone, instead of distributing first, they might just go straight into isolating the x. So then what's farther from the x right now? And look at what math the 7 is doing. So it's multiplying by the parentheses. What's opposite of multiplying? So you might see this as a first step, and that is reasonable. It does work. And it looks something like this. Do I need to flip the sign when I divide a 7 on both sides? No, because it's not a -7 at this step at least, okay? So I divided a positive on both sides. I'm gonna leave it the same. I encourage you to write this down too, so that way when you see it ever, it's not like automatic. That's the first step that's wrong. But then on the right side, what's 14 divided by 7? 2. And then you keep isolating x. What's farther from the x right now? How would I cancel that 3? Well, adding it would make it 6. Well, multiplying would make it 9. Subtracting 3 would make it 0. And that's what I want it to be if I want to not write it anymore the way it is right now. Whatever you do on one side. So then I get -x greater than -1. Is the x fully isolated? It's not. If there's a negative in front of it, it's technically not fully isolated. What number is written in front of it if it's not written? So right now it's being multiplied by -1. What's opposite of doing that? So we're going to do that on both sides to fully isolate the x. Do I need to flip the sign when I do that? Yes. And then same thing on top and bottom of a fraction. It cancels out to what's -1 divided by -1. Yeah. So same answer. All of these were acceptable moves. There might be some situations where you want to do that first instead of distributing, but otherwise, like if you have a choice, I would recommend just follow the distributing in the different step, if you can see that it's. All right, questions on that? All right, briefly, let's talk about the goal today, and that is to find and interpret solutions to inequalities in one variable. So the only difference between today and Monday's lesson is that instead of 2 steps, you might see other steps you have to do, like distributing, combining like terms, moving the variable, but still like same premise. We still want you to be able to graph the solution to an inequality on a number line. We want you to be able to solve them and interpret the solution in a real world situation, and understand that solutions to inequalities are not just one number. It's like a range of values that can be. I'm recording right now. I record every day, if you haven't noticed by now. So make sure whenever you are absent, it is your responsibility to watch the video. Everything you need to know is in that video. You could always ask me questions, but if you haven't watched the video yet, then I would say do that first, because everything you need to know is in there. Take notes on your own paper if you need to. You can always wait till you come back to get the notes, but know that I'm not like, here's Shruti, here's the things you missed. All right, that's not my style at all. It is your responsibility. You can grab them, do them on your own paper, I don't care, but you have to keep up with the class. So there's that. The practice today is lesson 19. It's in Schoology this time. The work from the past few days, if you want points for it, you have to upload it. So just make sure that you do. So do that. This one's in Schoology though. I try to keep them short and only for what's essential. This will probably be one of the last reminders I give you, but if you lost points on the most recent binder check, then it's your responsibility Anytime I'm not teaching, you can ask me to recheck your binder and I will. So I'll recount all the pages. I don't memorize what each individual person was missing. But your options to make that score better is to resubmit it, redo it if you lost the pages, or just do those IXL skills. The IXL skills go in that category for projects, so that's what you can do. Here's the assessments for this unit. I mentioned like this unit and the next unit are super short. Luckily though, you have fall break before you take your unit test. I mean, if it were up to me, I'd probably take it before fall break. But luckily, that's just not how the cards fell this year. You have a whole week to catch up if you needed to. So you have a whole week to work on your study guides, think of questions you could have asked for when you return from fall break. And that makes the test less than a month, but almost like a month away. So questions on that? So just keep that in the back of your mind. There is only one quiz this unit, a really short one, so you don't want to lag behind because it will be over before you know it. Now, in your groups, you are going to help each other answer these questions. So whether you want to like divide and conquer, whether you all want to try it and then compare answers, up to you. But here's the situation. The teacher is choosing between two options for a class field trip to an orchard. At Orchard A, admission costs $9 per person and 3 chaperones are required. At Orchard B, the cost is $10 per person, but only 1 chaperone is required. At each orchard, the same price applies to both chaperones and students. So you need to problem solve in your groups which orchard would be cheaper to visit if the class has 8 students, 12 students, 30 students. When you figure that out, you can move on to the next part, but we are going to go over this part in about 4 minutes, okay? So divide and conquer, talk about it, do it all together, but be ready in 4 minutes. Table 6. Which orchard would be cheaper if the class has 8 students? Table 7, which orchard would be cheaper to visit if the class has 12 students? B. Table 8, what about if they had 30 students? Which one's cheaper? Okay, so let's see if that's right. By problem solving our way through it. If you made an expression for each, great. If not, hopefully you can think about the real and know that if it costs $9 per person for orchard A, and I have 8 students, what math would I be doing to figure out just how much that part costs for the students? Would I do 9 plus 8, 9 minus 8? What seems reasonable? I'm asking all of you. Data? Because anytime it's per person, every something, trying to think of another phrase, but something along those lines, you are having to multiply to figure out how much you are spending for whatever the situation is. Like if it's just one person, it's $9. If it's 2 people, it's 18. If it's 3 people, it's 27. Like that is multiplying. Now that is accounting for the 8 students. What about the 3 chaperones? Do they have to pay for the chaperones too? Is there a different price for the chaperones? So really, I'm not just doing 9 times 8, I'm also doing 9 times 3, or just combine it. What's 8 plus 3? Not 12. 11. So however you did it, maybe you broke it up, maybe you did 9 times 8 and then plus 9 times 3. Same difference, right? But for orchard A, when we're comparing, we have to find the price for both. We know it costs $99 when there's 8 students, so 3 chaperones. Then for Orchard B, they have it where it's $10 per person and only 1 chaperone is required. So what will I be multiplying the 10 by? Table 1, can you tell me? How many people do I have total? So I'm talking to table 1 right now. So 8 students, Orchard B, how many people is that? What I think people multiply the 10 by? And then there's 8 students. Okay, and then 1 chaperone, that's a person too, right? They cost money too, don't they? Okay, so then how many people is that big limit? No, that is not 80. Guys, can we pay attention to the question I'm asking? Like, I'll start over. So table 1, are we paying attention now? Okay. So we're trying to figure out how much it costs for Orchard B when there's 8 students. The question I asked is, what do I have to multiply the 10 by? To figure that out. How many people is it when there's 8 students and 1 chaperone? Thanks, 1 was the only person. 10 times 9 is what, class? So it is cheaper for Orchard B by $9. So yes. People that said Orchard B, yes, it is cheaper because that's the math that we're doing. So then table 2, when I'm calculating it for Orchard A, so let's adjust this for a second first. What is changing each time? Class.
Students.
The number of students. The chaperones are not changing. It's for Orchard A, 3 chaperones, no matter how many students there are. So let's adjust this. We're not having to think so hard. Things that stay constant, like the $9 per person, the 3 chaperones, should be numbers in an expression. Things that vary, we should use variables. So the 3 is constantly there. What math are we doing when we're combining it with the students? Addition, and then the number of students is changing. Right, so now when I look at the rest of these, all I have to do is change my number of students. So like table 2, when it's 12 students, what am I multiplying the 9 by? That's what the tables that I call on to, but I don't need just like 1 person in the class to. That's why you take the time. The table 2, what am I multiplying the 9 by? Not just 12, because you have to add it to the 3. So in other words, what's 12 plus 3? Okay, so that's what I'm multiplying the 9 by. Class, what is 9 times 15? 135. That's how much it costs for Orchard A. For Orchard B, let's rewrite this so that it doesn't just work for one situation. In Orchard B, see what's staying constant. Is the price changing? It's always $10, so I should leave it as a 10 in my expression. Is the number of chaperones changing? So then that should probably be a number. So things that are same constant should be constant, same numbers. And things that are varying should have variables. So with the number of students, what math needs to happen with the one and the number of students? What math were we doing earlier? Because they count as people that they need to pay work to. So combine it with the number of students, combine means add. And now that is something that we can just plug these numbers into. So then table 3, what will I be multiplying the 10 by when there's 12 students? And then class 13 times 10 is. So why is, when I say class, like why is still one person answering? You know, you all need to know this, right? Okay, so again, 10 times 13 is what? So which one is still cheaper? By $5. Now, same thing again, except now we have 30 students. So table 4, when I have 30 students at Orchard A, how many people is that total? 33. So that I have to pay $9 for each of the 33 people. So class 9 times 33 is 297. Now table 5, what will I be multiplying the 10 by? How many people, how many tickets do I need to buy? How many tickets will it have? 31, because they require the 1 chaperone. Class 31 times 10 is. And so all the tables that said something, whether it was a guess or not, whether they looked at it online or not, because yeah, the answers are online. But the purpose of us doing this is not for you to just blindly copy the notes. It's so that you can pay attention and engage in the thinking process, because really, this was not hard to problem solve. You just count how many people are there and then multiply, because that's what you would do in the real world. So all so far we asked is which one's cheaper, and when there's fewer students, Orchard B is cheaper. When there's more students, Orchard A is cheaper. Now the next part, slow down a little too much. You are going to answer these questions about the same situation. So to help compare the cost of her 2 options, with Tristan, look up here. So to help her compare the cost of her 2 options, the teacher first writes the equation. 9 times the sum of n plus 3 equals 10 times the sum of n plus 1. Doesn't this look familiar? It should, because we created that. Hopefully you're taking the notes on it. All right, but it should look familiar, except now that the teacher puts in equals. And then she writes this inequality, so same thing as the equation, except for not an equal sign in the words, inequality. You need to answer these questions in your groups and be prepared to share no matter who is called on in your group. So make sure everyone knows. So you have to answer, what does the n represent in each statement? What does it mean when it's an equation? As in, like, what does solving it tell us? And what does it tell us when it's an inequality? Okay, graph the solution, so then actually solve it, follow those steps that we've learned before. And I'll give you 4 minutes to do that. So table 7, what does the n represent in each statement? Number of students. Good. I also happen to use the same variable because I think writing an S can get confusing, but For the way that they wrote it almost the exact same as how we wrote it. And when we did it, it was number of students. Okay, so yeah, writing n plus 3 is the same, has the same meaning. So then table 8, what does it mean, or like what are we figuring out when I put them equal to each other? How much until they equal the same? How much what exactly? Good try. What is the variable representing again? So how many students there are when they equal the same? Yes. To equal the same, cost the same, you could say, if you're wanting to be specific to the real world. But remember, like if we were to solve it, we'd get n equals a certain number. That number is still number of students, but it would just be when they're equal to each other, the cost for each orchard, right? So individually, this was cost for orchard A. I'm going to abbreviate it. For this one, it was cost for orchard B. So when they're equal to each other, I'm figuring out that they cost the same when there are this many number of students. We wouldn't know until we solved it. Okay, so that's what we're figuring out when it's an equation. There's probably just one answer for that. But when it's an inequality, table 9, can you tell me what it tells us the solution when we solve the inequality of it? That's 10 plus 1 is better than 9. So I guess it could tell us when exactly this expression that you listed out, was it for orchard A or orchard B? The 10 times n plus 1. Okay, so it's when exactly orchard B becomes greater or more expensive than orchard A. Greater / more expensive than orchard A. And we saw that at some point, once we got to a higher amount of students, orchard A was cheaper, right? At some point, orchard A does cost less. And that's what solving the inequality tells us. And at what values it'll always cost less. Okay, so that's the difference between the equation and inequality. Now we're going to practice solving it. But I just want to remind you of the steps, and I have space on the back for you to list those steps. So I don't think we ever just really wrote them. I mean, we talked about them, especially when we came to the study guides last unit, but now we're writing them. So on the back, you have a section that says steps for solving inequalities, and you can write these down. And then we can even start solving it on the back so that you have like an example along with those steps. So notice that the steps in purple are the exact same for when we're solving equations. The only thing that is different is what is starred in red, because that's the only way they're different. You only have to worry about flipping the inequality symbol when multiplying or dividing a negative number. Everything else is the same as when you solve the equation. Again, you have space on the back to write this. Steps for solving inequality. So the first step, just like equations, is to distribute if necessary. So does that mean you'll always have to distribute in every single problem? No, but if you see it set up in a way that you can, then I recommend you do that first. We saw in the warm-up that it can work without distributing first sometimes, but it's good practice and will work more of the time. Okay. So in the problem that's given, so I know you're writing down the steps, kind of try to pay attention as well. In the problem that's given, do I need to distribute? Yeah, I have to distribute twice actually. So that when I see that, I will do it first. Distributing here and distributing on this side too. Table 1, can you tell me what we get from distributing on this side?
Nine plus 18.
9 times 3, maybe 6 times 3 is 18.
Oh, 27.
Okay, great. So taking the outside number, multiplying it by both terms inside, that's, you can distribute when it's a number times parentheses set up like this, okay? Don't worry about flipping the sign for just distributing. You should just be able to copy how it looks. And now table 2, can you tell me what we get from distributing on this side? Are you sure? Okay, great. So taking the outside term, multiplying it by both terms inside, you get 10n plus 10. And that's just my first step. If you see that you can distribute, recommend we do that first. Usually after distributing, you do this next step, but not always. That's why it says if necessary. So you still should check, like look on the left side. Do I have any like terms on the left? No. No, look at the right side. Do I have any like terms? No. I don't. If you're thinking about moving it across, that's actually like the next step. So just check each side individually, no like terms. That's why it says if necessary, because you won't always have to do it. So combining like terms, they'd have to have the same variable to combine them. So say, let's pretend, don't write this down. Say that there was a plus 2n. Don't write that down. If there was, then when I get to this step, I'd have to do 10n plus 2n, which becomes 12n. Right? But I'm going to erase it because it wasn't actually there. Combine means add, so you're just adding the like terms together. Questions so far though? Okay. So I don't need to in this one. We're going to move on to step 3, which is move the variable to one side. That one should also be if necessary. So sometimes it's already on one side. But the step that's right after it is isolate the variable. You can't really isolate it when it's in 2 different spots. So you need to get them just be on one side. Does it matter which one you move? No. It doesn't. However, we recommend you move which one? The smaller one. The smaller one, because it's less likely you'll have a negative, which we know the sign flips with a negative. So like just it'll make your life easier if you move the smaller. How would I cancel it out on this side? Subtracting it. So this is smaller than 10n, so that's why I'm deciding to move it. I can't just like put plus 9n on the other side. I have to cancel it out on one side, and whatever you do on one side, I do to the other side. Everyone with me so far? Should be doing this one next to your steps, so that way not a big deal to go with it. I do not need to flip the sign when I'm subtracting, so just keep copying it the way it was given. Class, what's 10n minus 9n? 1n. And it's positive, I don't need to write the 1, but there's an n. The plus 10 is still there. We're not quite done yet, but now it's just one step, isolate the variable. So look at what's being done to it. And cancel it out so that it's alone. Table 3, what would that have to, what would we need to do, what would I need to do to cancel it out? Okay. Subtract it. And whatever we do on one side. So I get 27 minus 10 is 17. Again, I do not need to flip the sign when I'm subtracting. And there's that one. So when n, the number of students, is bigger, because that's where the opening is facing, bigger than 17, that is when your orchard B is, no, sorry, that is when orchard A is the less expensive. That's what we interpret it. I wrote over my number line, but if you are graphing it on a number line, it would look something like this. Make sure whatever number it's being compared to is included on your number line. It doesn't really matter where you put it, so long as you have some numbers that are greater, and they would have to be to the right, and some numbers that are smaller, those would have to be to the left. Open or close circle on the 17? Open. Open. Because it doesn't have a little line in it. And it's not an equation, so I should have an arrow. Did it go to the left or right? To the right, because these would be numbers that would make this true. 19 is greater than the 7. Or 17 is less than 19. Okay.